welcome. If you could please make sure everybody's seated, and we're going to welcome Steve Giguere for his presentation, Pwning the CI GitHub Actions Edition.
Nailed it. Just leave now. That was good. Pre-applause. You don't even know what I'm doing yet. Thanks for coming. I know you have options. I had a conversation yesterday at B-Sides with, I don't know if anyone knows Tanya Janka. She's doing a keynote on Thursday. And she said, oh, great, you're doing a talk. I'll see you. What day are you on? As long as you're not on Monday, because Monday's a tough day. Like, I'm Monday. Well, as long as you're not early Monday. I'm literally like the first session on Monday. So I appreciate you getting through lunch and coming out to this, because, yeah, it's actually a pretty good turnout, so I'm pretty happy. So I'll talk a little bit about this. I don't know if you've never spoken at RSA, you have to send your slides to them like 25 times. This is my first time. And they keep coming back going, no, I don't like that, change this. Or I don't understand that, change that. So I had to add this glossary slide. So if it sounds like I'm preaching to the choir about some of these terms, I'm sorry. But I did have to say, what is pwning? Because every time I do this talk, and it goes through marketing or it goes through somebody, they go, he spelled owning wrong, or they spelled pawning wrong, and they auto-change the word for me. So I have to tell them to put it back. But I did learn, though, that it comes from video games and trying to look up a definition of it, which is cool. But we understand it as taking unauthorized control or abusing the security of something in a general way. Git is a version control system. I know you know that. And a pull request, or short form PR, is a request by a contributor. And it's called, I think it confuses people, particularly salespeople, because the pull doesn't make any sense, because it sounds like you're pushing, but it's a request to pull your code into theirs. I'm going to keep saying these words, and I've got through it. Fantastic. Let's start with why. Why does this talk exist? Last year, some charming individual, I guess, created a bot of some sort that went looking for GitHub Action workflows and decided to submit a pull request to us. And this is on the open source project checkup. Actually, I'm gratuitously wearing the t-shirt that I work on, and decided to change. Now, please this is on a big screen because it's pretty small. But you can see we have a lot of things that happen in our build to assemble and release, and just a whole lot of other things. If you ever used GitHub Action Workflows before, or even Jenkins files or anything similar, you're probably doing a lot of things in your build. They deleted the whole thing, I think because we use a self-hosted runner. And they just replaced it with two commands, ps and env, to try and push all of our processes and all of our environment variables into the log. So obviously they could take a look at what it is that runner is doing and maybe work on something more nefarious afterwards. Very remedial reconnaissance on what we're doing. And our CTO at the time, he said to me, how bad could that have been? Like, it didn't run for a reason, which I'll explain, and some of you may know, but it didn't run. And so he said, play with it and let me know. So I did. Just a little aside on self-hosted runners. There's a good cheat sheet by GitGuardian. Apologies if you're with GitGuardian, I didn't capitalize the G's. By the way, all of the links in the bottom are on one big page at the end. I'm going to keep referring to links, but then at the last slide, they'll all be there in one, so you don't have to worry about getting them. But one of the points in the cheat sheet was harden your action runners, but more importantly, don't use self-hosted runners for open source generally, right? And we're thinking, oh God, we're an anomaly. Or are we? So I started searching for self-hosted runner uses of open source packages, and I felt a lot better that I wasn't the only one doing it. But it does seem that they're kind of being targeted by someone or something. So worth noting. Getting back to GitHub Action Workflows, if you're unfamiliar with, actually, I'm going to do a ad hoc poll. Hands up if you use GitHub. Cool. Anyone who didn't put their hand up, hands up if you have open source at all anywhere involved in any software you're working on. Some of you, so you probably do use GitHub. Because somewhere in your supply chain, there's probably a GitHub open source project that can creep in, which means no matter what I say, this probably still applies to you somehow. The workflows are where you can essentially create a little declarative / non-declarative application that does things to your application code. This is straight from GitHub. There's a few times in here I cut straight out of the GitHub documentation because whenever there's a bad practice, they're right in the docs. I like to highlight it on the screen. This isn't not a bad practice. It's just telling you what they're suggesting. A workflow to build and test, a workflow to deploy your application, a workflow that adds a label for new issues, and then I wrote, because it's something that we do locally, is sanitization of issue title or description, workflows for a variety of different reasons that can trigger on lots of different events. So all very handy, all very useful. Fundamental problems with GitHub and GitLab, and to an extent Jenkins and other CIs, is that they will often run the workflows even if they are part of the committed files. Under very minimal circumstances will they not run those files. So they've not been vetted, they've not been reviewed, they just execute because they're in the directory even though no one's really looked at them yet. This can be really bad, and that's what that guy was trying to do to us. Another problem is that metadata that gets passed into workflows like issue name or PR name or any of the sort of bits around it that get submitted often get used by GitHub action workflows. They just get blindly trusted. And I think it's a good point to stop and say, like, whatever happens in your workflows, whatever happens, whatever CI system it is, treat that like its own application. It's an application that deserves security in its own right because it is running code and it's operating on your other code. And for a while there, we weren't really thinking of it as a first-class citizen. The workflow directory has the same access controls as the entire repository, and that seems weird, but only certain people should really be playing around in that directory, yet any contributor of any status can do things like that, including someone who's never contributed at all can have a go at it. This is not ideal. So go back to these three. Sanitization of issue title, building and testing pull requests, deploying your application. What could happen? Well, if I'm playing with any kind of metadata that came in, and I'm using it in any of the sort of dash run, like everyone who does runs these sort of YAML files, there's always a way to actually run some of your own commands. And essentially, you're launching a little bash shell script. So there's a way you could possibly get command injection by that. So, okay, we thought about how we could do that. If I'm building and testing pull requests, well, there's always a token that's been passed in. It's only temporary, but how much power does it have? What can I do if I can push a new workflow that actually I know will run? Finally, if I'm deploying my application, all right, well, how am I deploying? Where is it going? What credentials are in there in order to enable that deployment? It's worthwhile to see if I can exfiltrate those credentials. And I know GitHub, for example, in this has secrets, but how secret are those secrets? So plan A is what this other individual did. Let's just create a workflow and submit it and see if it goes. Now, the only thing defending that workflow from running is that little tick box that shows up in the PR that says, this is a first-time contributor. Would you like to approve and run the workflows associated with this? And most of the time, you want to run your workflows because they're running all of your security checks. They might have some linters. They might have all sorts of other stuff that you have in there to do good, not to do bad. And if you don't read the help, and by the way, the words above there, they're from the little tiny blue there. It says learn more. You got to click through there to read that. And that's where it says, oh, well, but don't click it if there's actually a change to your GitHub workflows. There's a little warning there that says, don't do that. But you don't necessarily know in advance. We like to click things. This is the only reason that person didn't succeed is because we saw that and we didn't click it. That was it. Otherwise, they would have been successful. The second way to come in here is, this is the settings within GitHub by default. Require approval for first-time contributor. How hard is it to be a first-time contributor of an open source project? There's like 0 barrier to entry there. So I become a force for good. I go for a good first issue. I find a spelling mistake. You can always find one. Change it in the README. Presto, you're a good first-time contributor, and now your actual workflows will run. That's it. That's all you really had to do for that other person to succeed, which is why I think there was a bot that did it. All right, I have to come back over here because there's a few hands-on things, which is why I'm using my laptop, which is why they're very nervous about me. That I'm not using the correct laptop. Unsanitized inputs to workflows. In digging around, I found a lot of GitHub or projects that have action and workflows that do all sorts of weird things. This one was creating a blog article that was noting all of the GitHub event issue titles. And I was thinking, well, that's horrible. Because if that's going to be a GitHub-hosted website that's monitoring issue generation, even though I only have a limited number of characters, I could throw whatever I want in there if it's going to end up being on a blog page. It could be JavaScript. It could be anything that might try and trick the user who gets to that page into doing something they don't want to do. Far more often, I found thousands of examples that look like this, where they're doing something with the title. Now that doesn't look like, that's pretty innocuous, but if I create something with an issue title like looks a little bit like that, then bad things can happen. So I've got a pretty elaborate scenario here, and if everything works, I'm going to be really happy at the end of this. I think I have both of these on. Let's do that. So I'll show you what we've got. We've got a webhook sitting here running, waiting for things. I don't know if you're familiar with that. I have a netcat sitting and waiting. We'll get to that later. And over here, I have two characters. One, this person who has got a repo, and this person who is a contributor to that repo, who has already gotten past that first-time contributor. And they got past it by submitting a workflow. And that workflow is called issue title. And it looks exactly like the one we just saw. So what would I want to do after that is, well, I would come over here and I would maybe have somebody I know, maybe not the same person, come in and create an issue. Now, you understand the significance of the backtick. If you're in Bash and you run a backtick, it's going to resolve the contents of the backtick before it even looks at whatever it actually means. And you have an awful lot of leeway in terms of creating commands within there. So if I were to, say, put this in there, now this looks complicated, and you probably think there's no sanitization of this. Not really. And I create a new issue. Cool. If I go look at my actions, sure enough, that's running. If I come back over to here, I have all my environment variables now. That wasn't that hard for me to do that. It's very simple to submit something that looks helpful that can become malicious. So that's the first thing we started doing. Now, there are ways to limit the environment variables. If I'm only doing issue management, I don't need access to all the environment variables. I should use things like environment protection rules, environment secrets, just to make sure that I'm only scoping things to certain situations, and that can keep me a little bit safer there, but not totally safe. The best thing is just be sure that when you're using inputs that you are using them properly, because they are an application, and this is a traditional AppSec problem where if unsanitized inputs are definitely a thing, and they still apply in this situation. There's a really long link down there. It's really long. It's again at the end. Generally though, because it is that easy to get things out of the pipeline, always use short-lived tokens. I'm going to mess with that again a little bit later. Rotating keys, self-hosted runners. If you're using self-hosted runners, make sure you have role conditions, limit source IPs, OpenID Connect. These are all good things that you should do as terms of practices within GitHub Action Workflows. Because as you'll see a little later, it's not that hard to get the secrets either. All right, number 2, GitHub token abuse. So branch protection rules or the equivalent exist for pretty much any CI platform. You should have them turned on for your production branch. It's basically got all your security in there. If we take a look over at what I've got set up at the moment under my, I'm going to make it a little smaller so I can see everything. Go to my settings, my branches, and I haven't got any branch protection. I definitely should, so I'm going to turn it on. Now the one we're looking at there is require a pull request for merging. So I should have that on, because that would be bad if I didn't have that. I should also have a lot of other things in here. Like, for example, I definitely should have signed commits, but that's pretty rare that that's turned on as well. I should not have these turned on, but I'm just going to start with this one. Now, the important thing here is, I'm going to save this actually. So I've got oh, of course, I knew that would come back and bite me, wouldn't it? The important thing there is this 1. That's the default. And if you're not really paying attention, 1 really isn't enough for a pretty valid reason. Oop, let me go back to there and get past that, because I do need branch protection in place for later, just so I'm not looking like I'm making it too easy for myself. That's cool. What does that mean? Oh, okay. Yeah. Did you think the same thing I just thought? It's like, maybe screen capture that? That was cool. All right. So that's not necessarily great. Another thing that was interesting is this is what your GitHub Action workflow permissions should be. Last year around this time, a company called Cybersecurity, who conveniently, I work for Palo Alto, we just acquired Cybersecurity, so now I can go, yay, Cybersecurity. They noticed this combination of things. This is what it should be. Now, up until really recently, like as recently as I created a repository not that long ago, and the default settings were this, and yesterday I created the one for this, and the default settings were in fact that. So GitHub has changed this very, very recently so that this isn't the default anymore, which is great. But every repository before now has that as the default settings, which is crazy if you look at it. Like read-write permissions, that tick box at the bottom, allow GitHub Actions. Why would you ever do that? To create and approve pull requests? That seems pretty powerful. Like if you look at the distinction between one and the other, that's one set of settings, which is just a couple reads. And then that's what you got by default before, which is kind of a whole lot of everything. So what they did, and I realize it's a little small, but hopefully you can see it, they just did a pull request, and all they did was a run with a curl. And the GitHub repository is there, so that filled it in, that satisfied it. The GitHub event number was the pull request number. The GitHub token had the power, and you send the event approve, and suddenly they had a pull request that approved itself. Cool. That still works on most repositories if you only have one approver. All right, this is a little aside story. Just gonna double check my time, looking good. Using personal access tokens, and I'm gonna refer to GitHub's documentation again. Granting additional permissions. If you need a token that requires permissions that aren't available in the GitHub token, which means they're referring to automation, they're referring to GitHub Action workflows here, you can create a personal access token and set it as a secret in your repository. Awesome, that tells you how to do it. Which I found thoroughly interesting, that this is the advice that's being given. Because I thought, well, surely now somebody's gonna wanna do something that is beyond the scope of the normal token. So I went looking for anything that might be doing that, and I'm not gonna name and shame, but there's an auto-merge pull request GitHub action, where you can create fundamental rules that means you're not getting hassled with approvals. You can actually auto-merge something that's very simple. But it asks you to create a personal access token that allows for merge, which isn't normally there. So the next thing I did, okay, all right, so I know this exists. Who uses it? That's really easy to work out, right? Just a search for this action. I found an NPM module that's using this action, which means I know that NPM module has a personal access token that allows me to merge. I also know how to approve myself. So I could do an attack that allows me to extract, if I could get to the secrets, the personal access token, and I could auto-merge. And if I could do that, then I have a downstream supply chain attack. So there's plenty of opportunities at the moment to do that. So that's just a cautionary tale about using personal access tokens and creating them with any power beyond what. Be careful what you're doing. Back to the third one. So I'm gonna try and combine most of the things I've been talking about and what I've been learning into one sort of gigantic finish, and fingers crossed it actually works. Here, I'm gonna create a submission of a workflow, and I've got a few things down there, and I'm gonna just kind of bring that up slowly so you can see what I'm doing. I don't have access to the secrets because they're not environment variables. They're kind of localized only to workflows in a kind of environment variable format, but I can still echo them, and I can use them in the script to push them into a file. Cool. Well, then I could probably curl that file away, like I did with the environment variables. And for good measure, why don't I grab the environment variables? That's the same command I used earlier in the issue title. And now if I've got all this good stuff, say I'm successful, and I've got secrets, I've got environment variables, there's something there I could use, I don't want them to go away if they're short-term tokens. So I'm gonna stick something down there that hopefully keeps my workflow alive, so everything just doesn't vanish on me. So the last thing I wanted to do was that. Now, if you're familiar with, there's a million ways to do this sort of thing, right? But that's one version of a reverse shell that's gonna send me a shell out to a remote location, which you saw earlier. I have a little VM sitting waiting for something like this. So let's take a look at what that actually does. Where are we? So here's my bad attacker. And let's go to my pull requests, of which I have none. I'm going to go into my workflows. I'm going to add a file. I'm going to, what are we going to call it? Let's call it something that is super obvious. Pwn.yaml. If I were a hacker, I would never do that. Pwn.yaml, that's pretty suspicious. But I'm doing it for entertainment purposes. I'm going to grab what I just showed you, paste it in, and you can see I've got that auto-approve in there just for fun. Okay, that seems pretty good. And we can see I've got my branch protection in place, which is good. I can't just push this directly in. I'm doing some security. And I'm going to call this RSA, caps lock on, work. Trying to give me some good luck. All right. Pwn.yaml, perfect. I'm going to create a pull request. Okay, and you'll see, like I had said earlier, it's actually starting to run the workflow that I submitted, which to me just still to this day seems bonkers that that's allowed to just go. And it just failed. This is the hazards of doing live demos. One second and I'll redo what I just did. We'll kill that. We'll go again. As you can imagine, I did this earlier today, and it worked fine. Now I'm getting trigger happy. Cancel. All right, p.yaml, don't hit enter too soon. Okay, still looks okay. Sure. $RSA. So part of it worked. One more go. Be patient, please. Okay. So the first thing that worked was it actually got approved this time. I have no idea what went wrong before. Who cares? So the auto approval worked, and you can see it's been approved by the GitHub Actions bot, so that's cool. The other bit that was interesting is over here, I now have GitHub tokens, auto merge pat, among other, all of my secrets have been exported along with all of my environment variables. So the secrets method worked, the environment variables worked. It's still running, and it's running because I'm now on the runner live over here. So that's cool. Now what can I do now? I've succeeded in what I thought I was going to do, which is nice. And now I have to just do a few. This is where I started experimenting with what I could do p.yaml, just to remember the name of the file that I was using there. Okay. So how much power do I have here? Let's run a little bash script. And then run another little bash script. Now, something I wanted you to notice right now. Anybody heard of that guy? He's fairly instrumental in creating one of the most popular operating systems on the planet. So I can come back over here. And you'll notice something's changed. I didn't do anything, but my PR is closed. As I go to pull requests, there's no pull requests. I go to closed, and I look at that one. I see files changed. Hi from Linus. Is it him? Yeah, it is. Cool. Turns out if you just set your config to an email that already knows, not only does it accept it, it applies a little avatar. So if I know any of your emails, I can spoof you and make a change, provided we're not using signed commits. I can make me look like you, or someone like that. What's also cool is that if I go to files changed, sorry, it's broken. So while I could track this down, in the first instance, it makes it very difficult for someone at a glance to see what just happened because the actual workflow file is gone. It's no longer in this branch. There's a little hello world from Linus Torvalds. Awesome. So now I'm actually deleting my tracks, but I'm also still resident on the runner, which is pretty handy. So I could progress pretty far from here. Like I could create a slightly better shell if I wanted, and you can see my identity as runner. Or I could even, because I know that on most runners, Docker with a Docker socket is resident, I can run a very simple Docker command, and now I'm root on the runner. So now I can just go from wherever I want. I'm on a self-hosted runner, and I've got root access, and off I go. And I've deleted the pull request and hidden my tracks on GitHub. So some very basic branch protection, some signed commits, just some fundamentals that are simple tick boxes in your GitHub repo really go a long way to stop an idiot like me from doing these sorts of things. So I'm going to get out of here because that is on a GitHub runner, and I'm sure they don't like me doing that. So what happened is I got all secrets, I got a personal access token, I got environment details, I got a persistent reverse shell, and I covered my tracks and pretended to be somebody I wasn't. Which is cool, kinda. Except for it's too easy to make that happen. So that was kind of that was the end of my discovery, and then started looking into what else could I have done there. We played around with a few other, friendly self-hosted runners just to see how bad it would be, and found an awful lot of information exists on self-hosted runners because people just never expect you to get there and start poking around. You can find AWS secrets are embedded in there. I was able to change the logging level so that I could use the logging to actually give me more information that I thought I would need. I was able to find alternative code that might be there if it was a shared runner. I still had all the tokens because it was still alive, so I had a long time on that runner. The timeout is huge on GitHub runners, like an hour or 4 hours. I think it's 4 hours. I was able to find processes running. If I was containerized, it was very easy to determine I was containerized and potentially pop out of the container and get more access to even more and be able to learn the network. We also noticed that there's a lot of self-hosted runners for people who just let us experiment that had access to S3 buckets, had access to registries that did not have immutable tags, which meant I could live on this runner and I could start pushing my own images and overwriting tags. So the potential for what I could do simply by getting access to a self-hosted runner was huge. So how do we prevent this kind of things? Well, you kind of saw everything already. I mean, self-hosted runners and public repos obviously were being targeted by somebody, and it seemed weird, and now it seems like, frankly, from an offensive perspective, a great idea. Be careful if you're adding contributors. I know when we started off on Chekhov, we just wanted anybody to help. So we were just like, yeah, sure, new contributor. We didn't do a whole lot of vetting of the people who ended up in the project in the early stages. And who knows, right? When you're starting a project, you don't realize it's going to end up being as big as it is. And the early stage people, you maybe have no idea who they are. Always turn on branch protection and tick as many boxes as you can possibly get away with as early as possible in there. Always for the production, more than one reviewer, and change your run flow settings to be more than first time. Never add, never trust GitHub secrets, I suppose is what I'm trying to say. By the way, never add tokens to workflows if possible. Obviously, preaching to the choir a little bit here, but at least privilege that token needs. OpenID Connect is great. Use the event logs to log activity. And last point is the code owners file. Code owners is a very simple file. You just put a single reviewer's name in there, and if they need to be the one to review it. So that auto-review, auto-approve doesn't work if there's a code owners file in there, in the GitHub directory. It's the easiest way to prevent that very simple attack. And enforce signed commits. I know we didn't have signed commits on forever on Chekhov until we started playing with how bad it could be without having signed commits. And suddenly it all became very hot that we needed to have that. Now, tools that we started using internally, OpenSSF scorecard is great. It does check a lot of the things I'm talking about now to make sure that you have branch protection. Not only that, but you have the right settings in your branch protection. It looks for dangerous coding patterns. I tried it on some of the things that I did, and it was pretty good at finding them. And make sure that your GitHub workflow tokens are read-only, so that setting that wasn't default, it looks for that, which is cool. The alternative, which was the outcome of our work in the first place, is the tool that I work on. We added all sorts of weird stuff in there, like anytime there's a curl being executed, if it has access to secrets in the same section, well, we're finding ways of doing that, looking for patterns that represent reverse shells, unsimultaneous input, some of the crossover with OpenSSF, but then also some that are slightly different. And then we also added checks for the CI/CD environment generally for Bitbucket, GitLab, Circle CI, and of course GitHub. So we added a lot of different checks to make sure those environments are solid now, based on our own experience, because we needed them for ourselves. Just a quick look, this is what Chekhov looks like when you run it. There's two examples here. One we're looking for curl and one for the shell injection that I did. Obviously, I'd written that as a test for this thing, and so then I had to write a check to make sure that it would actually find it in the future, among other variations that might do the same thing. So that is, I'm definitely on time. Cool, man. That's the end. Thank you very much. I hope you learned something. Have a great RSA. If you have any questions at all, please use the microphones. I've been told to tell you that, because then I don't have to repeat the questions. If not, cool. That means it went well.
Hello.
Great.
Thanks for a great talk. I have a two-part question. First part is, did you reach out to GitHub or GitHub Security Lab about this?
Yeah.
And the second part, if so, what was their reply?
Well, the first one was from Cider, and they reached out, and the reply there was those settings weren't always the same. So they're actually remarkably fast at reacting to things. And so just changing the default settings, like if you go for the read-only, almost everything I did didn't work, with the exception of the Docker accelerate to root. But then if you've ever written to a major organization about why, and it's showing you what you can and cannot do, they usually explain away some of it as being my responsibility to harden my own runner, et cetera. And they have a very good hardening guide, which is somewhere in there. There it is, last one. So they improved the hardening guide, and then they changed the settings. That's essentially what happened. So that the default, but they couldn't change it to be default until now, because a lot of people got upset when they changed the read-only to happen right away. So I think there was like a 1-year time limit before that change, which only just happened, if that makes sense. Was there a second part to it, or was that the second part?
So let's say maybe like the fact that you can make a commit making it look like it's Linus Torvalds. Did you reach out to GitHub Security Lab?
Oh, they
about
know
this?
that. They're fully aware of it.
Okay, and their reply was, oh, just turn
People
on
should
signing.
use sign commits.
Okay. Well, that's an answer, right? So
Yeah.
thank you.
It's like they have a mechanism to prevent it. If people don't use it, there's nothing they can do about it.
Oh, well, thank you.
Okay, no worries. Cool. Yay.